once we see the process of getting an inverse for sine, we can cut off the other ones in a similar manner. Now if you look at cosine, starting at 0, if you go back or forward from there, it almost instantly doubles over. But if you started from 0 and moved forward, you could go all the way down to here before it doubled back, right? So for cosine, what we're going to do is cut it off between 0 and pi. So to get an inverse, in other words, we're going to cut off the domain of the original function cosine to be between 0 and pi. Then when we get the inverse is going to take a number between -1 and 1 and give us back some angle that is between 0 and pi. So the cosine inverse, or the arc cosine of a number, is the angle between 0 and pi whose cosine is whatever x you're given. Okay, so if someone asks, alright, what's the cosine inverse of, let's say, -√3/2, then you're looking for the angle whose cosine is -√3/2. Now we know it's an angle between 0 and pi, right? So it's an angle up here between 0 and pi. And if the cosine is going to be -√3/2, it's going to have a negative cosine. That means it's got to be over on this side. And of course that angle is 5π6, right? So the arc cosine of -√3/2 is 5π6. We knew to choose that one. There are others, right? There's one here, 7π6, would also have a cosine that's -√3/2, but it's not, 7π6 is outside of the range, right? Also -5π6, that would be this angle here. That has a cosine that is -√3/2, but it's not between 0 and pi again. So that's how we choose the particular angle that we want, right? It's from the definition of arc cosine, so that it's going to give us the angle between 0 and pi. Let's see. If you were asked to find the arc sine of -√3/2, that's asking for the angle whose sine is -√3/2. Remember, arc sine always gives an angle between -π12 and π12, so it gives an angle somewhere over here. Of course, if the sine of the angle is going to be -√3/2, you know that it's an angle down here in quadrant 4, right? So you know it's going to be an angle like this, and we recognize that that angle is -π3. Okay. We chose that particular angle, even though there are others, right? There's one over here, right, whose sine is -π3, but that one doesn't work because it's outside of this range between -π12 and π12. This is the only one that's between -π12 and π12. Okay, so sine we cut off between -π12 and π12. Cosine we cut off between 0 and pi, and that's how we get our inverses. So we know if we take the inverse cosine, we're going to get an angle between 0 and pi. If we take the inverse sine of some number, we're going to get an angle between -π12 and π12. Let's do some more. Let's look at the tangent. Now, we need to cut the tangent off, and the most natural way, or the principal branch here, is to cut it off. Let's see, starting from 0, you could go all the way to π12, right? So cut it off there, and you could go from 0 all the way back. So this might be a nice way to cut it off. Just take off these bits. Right? Now we have a function that passes the horizontal line test, so it has an inverse. Okay, so that means that if we cut off the tangent so that it only works on angles between -π12 and π12, the arc tangent will take numbers here and give back angles that are between -π12 and π12. So the arc tangent of x is usually taken to be the angle between -π12 and π12 whose tangent is x. Okay. So for example, if somebody asked you, what is the arctangent of -1? Okay, you could think, all right, well, I know it's an angle somewhere in this range, right? Somewhere from -pi/2 to pi/2, and the tangent of that angle is -1. So that would mean that the sine of the angle over the cosine of the angle is -1, so that would mean that the sine is the opposite of the cosine, right? If the sine's the opposite of the cosine, you've got to be down here somewhere. And if they're opposites, that's got to be the angle minus pi/4. So the arctangent of -1 is minus pi/4. Let's do another one. What about the arctangent of 1 over √3? Well, we know the arctangent was, if it's 1 over √3, that's a small number, right? So the sine must be smaller than the cosine, and we recognize that that's pi/6 because the tangent of pi/6 is 1 over √3. Okay, there are other places where that happens, like over here, right? Oops, yeah, because the sine and cosine are both negative here. So this angle, 7pi/6, also has a tangent that's √3, but it's not in the correct range. Pi/6 is the only one that's between minus pi/2 and pi/2. But this one, the arctangent of -√3, let's see, that is going to be -pi/3, right? That's the only place between minus pi/2 and pi/2 where the sine divided by the cosine is -√3. I knew it's down here because if the tangent's going to be a negative number, like -√3, then the sine and cosine have to have opposite signs, which only occurs here if you have to stay between minus pi/2 and pi/2. Okay, I'm getting the hang of doing this. Let's do it for the cotangent. So the cotangent, let's see, where would be the natural breaking point here for the cotangent? You could maybe go from minus pi/2 to pi/2. That would work. But the most common thing is to go from 0 to pi, like this. So we just take that part of the cotangent and throw the rest away so that it will have an inverse. Okay, that's the most common way that cotangent is defined. So the cotangent inverse of x, or the arc cotangent of x, is the angle between 0 and pi, whose cotangent is the given number. Okay, so if we wanted to find the arc cotangent of, let's see, what's the arc cotangent of the square root of 3? So now let's maybe do the negative square root of 3 just so we can consider the issues here. We know that we're looking for an angle between 0 and pi, so an angle up here. Of course, in this region, the sine and cosine have the same sign, so and the cotangent is cosine divided by sine, and positive divided by positive will be positive. So for all of these angles, the cotangent is positive. We're looking for an angle whose cotangent is -√3, so we know we've got to be over here. Since it's sine, this is a number bigger than 1, so it must be that the cosine is greater than the sine. And we can see, that occurs at 5pi/6, right? Because the cotangent of 5pi/6 is equal to the cosine of 5pi/6 all over the sine of 5pi/6. And we know that the cosine of 5pi/6 is -√3 over 2, and the sine of 5pi/6 is 1/2. If you multiply this fraction top and bottom by 2, you get -√3 over 1, or just -√3. So this is the angle. It's the only one between 0 and pi whose cotangent is -√3, and so the cotangent inverse must be 5pi/6. Now so far, I've only looked at numbers where you could easily figure out the angle, right? So we know what happens at multiples of pi 6 and multiples of pi fourths for the sine and cosine, and therefore for the other 6 trigonometric functions. We could always figure out those nice values. But if it's not a nice value, then you're going to probably have to use a calculator. And the problem is, let's say I asked you to find the cotangent inverse of 1/2. You know you're trying to find the angle between 0 and pi, whose cotangent is 1/2, but there's not, so unless you're going to guess and check at what that angle is, right, just keep refining the angle, trying to get the output closer and closer to 1/2 by taking the cotangent. Unless you're going to do that, you're going to need to use a key on your calculator, and you'll notice that the calculator usually only has keys for arcsine, arccosine, and arctangent. So what are you going to do? Well, the key is to look kind of closely at the graphs of tangent and cotangent as we've cut them off. Here I've got the graph of tangent. Remember, we cut it off between minus pi halves and pi halves. And then over here I've got the graph of cotangent. And you can see there's a relationship here, because if I slide cotangent over to the right by an amount pi halves and then flip it over the x-axis, then I'm going to get the graph of cotangent. So the graph of cotangent is the graph of tangent shifted right and then flipped vertically. So that means that the cotangent of an angle is the same thing as the negative tangent of x minus that angle. Remember, this is the transformation that shifts things to the right by an amount pi halves, and this is the transformation that takes the graph and flips it. So because that's true, if I'm trying to find the angle whose cotangent is a particular value y, then that would mean that the cotangent of the angle is y, right? But then the cotangent is the negative tangent of x minus pi halves. So I could replace the cotangent with this. Now tangent's an odd function. You can see it has symmetry around the origin, right? So that means it can bring this negative inside, and you get pi halves minus x equals y. Now I can solve for x. Okay, so pi halves minus x will be the arctangent of y, and I can get x alone if I bring the x over here and the arctan over there. Pi halves minus the arctan of y is equal to x, or let's see, x was actually the cotangent inverse, right? So you can find the cotangent inverse of a number. Oh, yeah. X was actually the cotangent inverse of this number y, right? So you can find the cotangent inverse of a number by taking pi halves minus the tangent inverse of that number. Let's just look at that example that we had. We wanted to find the cotangent inverse of 1/2, but there wasn't a cotangent inverse key on our calculator. So we're going to do pi halves minus the tangent inverse of 1/2. So if we bring up our calculator, if we want to find the cotangent inverse of 1/2, we can't do cotangent inverse because there's no such key, but we can relate it to the tangent inverse. All I have to do is take pi divided by 2, there's pi halves, and now I'm just going to subtract the arctan of that. So put in 1/2, right, and then use your inverse key and hit the tan. Okay, put that together, we get 1.107 as the answer. Now we can check this, because if this is right, then the cotangent of this angle has to be 1/2. Of course, the cotangent is 1 over the tangent, so the tangent of this angle needs to be 2. So we can just check this really quick. 1.107, if we take its tangent, sure enough we get 2. Since the tangent of that angle is 2, we know that the cotangent is 1/2. So 1.107 is our answer in this case.